All right, so if you are here in this session, it means that you're interested by having a comparison between different runtime agents, security runtime agents. So in the abstract, I was initially covering Tetragon, KubeArmor, and Falco, and then when I was doing the benchmark, I say, what about adding another one? So I just added Tracy. So I'm sorry if you're going to have more slides just to cover another solution. I'm really sorry about that, and I hope you will enjoy. I like to have energy from the crowd, otherwise it's going to be boring, me talking, so try to be interactive with it, that would be great. So let's introduce myself briefly. My name is Henrik. I am a cloud native advocate at Dynatrace, so it's been about 4 years, mainly specialized in Kubernetes and observability in general, and then I started to be very interested in security because I think security is almost like a small part of observability as well. And prior to that, I've been spending all my career as a performance engineer, so testing, breaking, tuning things, at least having fun. So that's why performance is still on my heart, so I try to produce content when I have time on a YouTube channel called PerfBytes on the bottom. For those who never heard about it and you're interested in PerfBytes and performance engineering methodology, check it out, it's out there. And since 3 years now, I started a YouTube channel called Is It Observable? Same thing, the QR code is here. And if you're interested, you can check it out. So, before we start, I need to have a disclaimer. When I prepared all those tests, I can guarantee that no eagle, no shields, no Spartan has been armed when building these presentations. So I was very gentle with each of those tools, and I can guarantee that they were still running, no issues on that side. The intention here of this presentation is not to blame any tool. The idea is to look at the tool, share the feedback to the projects, and again, this main objective of this presentation is give you some tips, share the results of this benchmark, and help you to pick and choose which agents fits the most within your environment. So I think we can start. Welcome to the Cube Olympics 2024 Salt Lake City. I hope you all enjoy this event. We all know these events because it happens every year, and we're all supporting teams. And for those who never heard about the Cube Olympics, let me remind the principle. So there are various practices in this event where we have different categories, and every tool is competing between each other. So we have the community lifting. We have the developer experience, we have the observability layer, we have security. And if you're in this room, sorry, we will cover mainly one of the sections of the sport, which is the runtime security agent. So if you're looking for observability competition, you should go in another room because I won't cover observability today. All right, so let's present the athletes of this super final. The super final will be covered through Falco. So Falco has been trained by the Cystic teams. He's been out there since many years. And he has involved with ebpf over time and provides a really interesting approach. So he's trained, he knows how to do things. We'll see he has advantage and disadvantages. The second competitor is Tetragon. Tetragon coming from the Cilium dojo. He's been born with ebpf, so he's embracing ebpf, whatever he's doing. So it's very powerful, you'll see. And we'll see if he has advantage in this competition. The third competitor is KubeArmor, the Spartan, the new player of the market, I would say. He sees the security in a different angle compared to the other competitors. And he is also, of course, being trained through ebpf. So ebpf is also part of his mentality and his culture as well. And last, we have Tracy, coming from Aqua Security. They have been doing different open source projects. Tracy is one of them. If you probably know another project that they have provided on the market called Trivia Operator that do a lot of image scanning and everything. So Tracy has been out there since a couple of times. A couple of users are using it. So let's see if Tracy is interesting in this final and see how it goes with this competition. So if you stay here, I hope you will stay with me, honestly. We will touch base on a few things. I will basically try to compare and measure each agent based on different criteria. So the experience to build the policies and construct the security enforcement that you want to have, Then we will cover the components, because every solution will require components running in your environment. And last, there is the observability piece, because of course, when you're running an agent but you don't see what happens, it's going to be quite annoying. So we need also to get feedback somehow. And also to one interesting angle that we'll cover at the last is performance, because at the end, it's great to have agents running there, but if they are very expensive, then yeah, we can consider maybe removing some policies. So we will have different stage. And before we go to the stage, let me remind the rules of this competition. So we're going to cover a couple of sections. We will have capture and filter, which is a bit the same approach. So that will be mainly the design aspect. So I will try to remind what we need in these sections and what each of solutions cover in that section. Then we will measure, of course, see the components involved, what are the components we need to run those agents. We will look at the observability again, like I mentioned, and last, the important aspect is the performance. So, are you ready for the stage one?
Yes.
Okay. Okay, so I need your help. So stage one, and you say components, okay? Stage one? Ah, great. I love it. All right, so let me remind the things. So components. Here we need to capture events that will happen in a system. And usually those events is on the kernel, so the best way to do it is to rely on ebpf agents. So what we expect from a component perspective at the end, obviously, is to have a daemon set in our cluster, and that daemon set will deploy those ebpf probes. So that will be the mandatory requirement when we deal with those solutions in each solution that we cover. So let's cover each solution. So first, we have Falco. So Falco, of course, has this daemon set, as expected, and then he has another component called the Falco server, which is, we'll touch base on later, it's mainly a rule-based engine. So it's not an operator, it's a server. And then you will see that it's not required, but we usually use it. It's Falco Psychic, because at the end we need to have get the data out of Falco, and Falco Psychic will be a component that we may use at the end. Then we have Tetragon. Tetragon, out of just the agents, it has an operator. So if you have an operator, it means that you have CRDs. So the CRDs are there mainly to help us design those policies and introduce, in fact, 2 CRDs, and we'll touch base on them later. We have KubeArmor. KubeArmor, same thing. We still have the agents. And then you have an operator, as expected, that introduces more CRDs. We have the configuration. We have the, we'll touch the cluster, the one from the namespace, the one for the host, and so on. And then it has 2 extra components. So you have a control server, the name I don't remember, but it's control something. And then we have the relay server. And so there's more workload involved behind the scene. So maybe that brings an advantage somehow with the solution. So we'll touch base on this later on. Then we have Tracy. Tracy is a bit similar to Tetragon. The agent, the operator, which means we have CRDs. And here there's only one CRD exposed. It's the one that will configure our main policies. So at the end here, there's no clear winner. We just see that KubeArmor brings more workload in our cluster. Does it bring value? I don't know. We'll see later on the performance aspect. So let's move on to the next stage. So stage 2.
Capture and filter.
Ah, great. Thank you. All right, so capture and filter. What do we expect from the capture and filter? So capture, usually a suspicious event in the cluster is, I don't know, I'm running a process, suspicious process spin up, and then he wants to reach out to a file or doing some network activities. So I need to capture process information, I need to capture file access information, I need to capture those network details and everything. But capturing those events is great, but we need to have to store details about it. So the process name, the process path, the executable, the binary. We need to have the file, all the file details. Which user triggered that action, which group, which capabilities, which namespace from the kernel perspective. And of course, we need Kubernetes metadata because at the end we need to attach it to a workload or to a container. So that is what we expect when we capture. And when we filter, so we have events with data, and then of course we don't want to sniff the entire traffic of the cluster. That will be very expensive. So you want to be able to filter, say, oh, please just look at this specific process or specific file So then having the options to filter by process, by details, by user details, by namespace, spot, whatever, that is really important. The other thing, which is, I think, not a required, but it helps to simplify the usage of the solution, is to have predefined rules. Because at the end of security, usually you have common pattern of attacks. So having rules that are predefined for us and not having this journey of configuring them, that is so great because you don't have to recreate the wheel. So predefined rules, I think, from my perspective, is important. And last, of course, detecting things is great, but being able to react, it's much better. So let's see the oyster solution. So starting with Falco. So Falco here, to remind, it's a rule-based engine. So the idea is that you produce log if an event comes in the rule-based engine server and says, okay, it matched, so I'm going to throw an event, a Falco event based on the rule. So at the end, usually most of us in the industry, we use their daemon sets, so the kernel agents that will capture those kernel events. So then you can build the rules based on the kernel events. But you can have also plugins, external data coming in. And the great thing is you have SDK, which means if you want to, I don't know, create your custom rule that detects something outside of the cluster and feed it into Falco, that is actually possible. But if we focus just on the Falco agent, on the kernel, of course, we'll have the process details, the syscalls, everything we mentioned before, it will be there. So don't worry, you will have all the things required to build your rules. In terms of the event produced, the structure is well detailed. You have a lot of things, but one thing is every event from Falco is the structure is different. So we'll touch base on the observability side. The fact that it's so, you can have random different format, it makes the processing of that event more complicated. And this is where, for example, we see touch base Falco Psychic makes sense. So the Falco rule here, the idea is that the agent, when it starts, it has a file that you load in the agent. And so that's great, because at the end you have a global file. But the disadvantage, I would say, is that you cannot reload. So if you want to add an extra rule in Falco, you have to stop the agents, add your modification, and restart. So that is the philosophy of Tetragon, of Falco, sorry, as of now. But it has a major advantage, is that all those rules here, because it's a common rule, you can reuse filters. And usually you always have the same type of filter, say this process with this file system. Then because it's the same, you can create macros and reuse existing conditions. That's, I think, is quite smart. So you don't have to repeat the same rules on and on and on. Of course, when you define your rule, you define, you can filter by file path, by stuff, by all the details we need. And the way I'm saying the event is different, because here you can see there's an output, and this is going to be one of the fields that will be exported in the event. So depending on how you define your rule, of course, you can define whatever your output you want. So that makes the parsing more complicated. Let's move on to Tetragon. So Tetragon is, by default, when you deploy it, with the default settings, it will capture whatever process executions and process exit happens in the cluster. That is configured like this. And then, of course, if you deploy your own tracing policies, this is a CRD that configures Falco, it will produce events based on the events that match the policy that has been defined. And when Falco is really in the ebpf philosophy, so you attach, it's a notion of attaching a kprob, so kernel function, uprob, user functions, trace points, kernel events, and then you can also have LLSM. So it's really powerful. We'll touch base on in the next slides. And the way the event is structured, it's wow, it's so dense. You have the process, the parent, you have so much details. You will see touch base on observability. It has a major advantage, also maybe a disadvantage, because it comes with a price. On the policy side, well, first you have to attach the hook point. Is it going to be a kernel function? It's going to be uprob. Once you have it, you don't have to create plugins. It has a way of capturing the functions. But the problem is that here, I am looking at, I want the index 0 from the function. So first you need to figure out what is the index 0 of the functions. So you need to know all the functions. And then also when you capture it, then you say, okay, now I need to convert it to have a human text out of that function. So you need to map it to a type. So that brings this configuration quite complex. So So you need to know a lot on the kernel side to make it very useful. And then, of course, once you have that defined, you can then create filters, so selectors, based on the capture details, based on process, then user, based on everything at the end. So powerful. And then last is, of course, Tetragon has the ability to enforce, but not just block. You can do so many great things about it. That is crazy. And one downside, I would say, with Tetragon, even now they have a repo with examples of policies. They don't come with predefined rules. So you have something that is completely empty, and then you have to be creative. Or you have to go to repo and look at what the neighbors did to start up your adventure with Tetragon. KubeArmor is when you deploy it, it's not going to produce any events, nothing. It will basically only produce events once you deploy policies, which makes sense. And also, you can also have an option to say, I want to turn on events. So you can then get events from process details, file details, network details, and so on. So at the end, it captures everything we need, the process, the file, the networking, what we need. What is interesting compared to the other is that this operator works with annotation. So the way you want to add extra events is based on annotation. Oh, I want to have details about that pod. So I'm going to annotate that pod, and I will have the details. Or I want to have annotations, details about the namespace. You can do that. And also they have another annotation, which is interesting. So you can make a policy that says, oh, whatever happens with the network, I will be audited. So it's just an event without blocking anything. But then in this particular namespace, this is really serious. I'm going to block it. So you can have an annotation where you can change the way it's going to react. And that is completely different from the other solutions. So that is an interesting feature, to be honest. Other side note is that the events produced by KubeArmor is super standardized. It's very hard to read it. You may have less details, that's true, but everything is there, so if you have to parse it with a solution, it's plug and play. The policy itself, they have separated the policies in cluster policies, host policies, so the node, and then the policy that you can target a namespace or a pod. So in the policy itself, you can create a message, a tag, of course, the rule itself. And then, of course, the difference with the other solution, I mean, like Tetragon, you can create an enforcement rule, but here you have two options. Audit, allow, or 3 rules, allow, audit, or simply block. And KubeArmor doesn't come with any predefined rules. They have a repository, which is interesting. But again, if you look at the repository, they went very far. There is, I didn't count the number of policies they have there, but then you've been lost to search which policy I should use. So it's a bit more complicated, to be honest. Now we have Tracy. So Tracy, when you deploy it, it will produce only events based on the policy deployed. And what is great, similar to Tetragon, when Tracy is deployed, it comes with a default policy. So it captured the most well-known security events that happens on the cluster. So you will have, at least without doing anything, those common problems. The way it works is that it works with signatures. It's called signatures. Compared to Tetragon, remember, you have to, I want to have this index, and this is the type, so then you can decode the details. Here you use a signature, it's a piece of code, that says, this is the event, and I want to extract this piece and decode it. So at the end, when you use those signatures, you don't have to worry about how you're going to convert it. It's already done by the signature. So that I think, from a user perspective, it's great. So it helps you to figure out what you want to decode and what you want to capture and how you want to decode it. And last, Tracy, of course, comes with an SDK where you can customize those ideas. In terms of the event produced, it's very structured. The only difference, of course, is the output of the functions, because one syscall will give you details, another syscall will give you the other type of details. So again, parsing will be easier, but there is this minor things on the details of the function itself. On the policy side, it has only one policy, which is the policy CRDs. The policy CRDs seems very simple. When I looked at it, I said, this is very, very lightweight. But in fact, at the end, you define a scope. Is it going to be global to the cluster? Is it only on the container side? Is it only not container aspects? Is it only based on a specific user? So you define the scope, and that will filter where Tracy will look for those events. And then you create your rules when you say, oh, I'm interested in that specific signature. So let's say the VFS read, if you want to look at the read, access read on disks, on files, you can do that. And then you can create your filters. So you can create filters based on the data extracted from the signature. You can create filters on namespace, on process. You can, all the things that we required are actually there. So to summarize this capture and filter section, capturing and filtering, all those solutions has the feature that we need. Nothing is different. I would say that the differentiation will be on the default policy. It's only Falco and Tracy that comes with the default rules configured. And also the way to react, to block, there's only Tetragon and KubeArmor that provides that feature. On the customization side, so I mentioned an SDK on Falco, so you can create your own events. And Tracy has the ability to create your own signature. Tetragon, I put it customizable because at the end with this philosophy of hook points, kprop, uprops, where you can do, if you're creative and you know the kernel, you can do everything. So I think you don't have to code, but you have to know what you want to capture, and it's so customizable, it's insane. So here I would say that in this KubeArmor has a slightly disadvantage, but again, it's very low on that side. Stage 3. Okay. All right, so observability. What we need from an observability perspective. So at the end, security exposed events, we mentioned about this. So at the end, with those events, we can clearly extend the level of observability by just collecting those events. So of course, we want to be able to collect those events by relying on the logs, because you may have those events in the logs. And then once we have captured those logs, we want to be able to parse the logs. And this is why I mentioned the event structure is important, because it will complexify this journey of parsing. And then the other thing is those events could be very rich, especially Tetragon. So having an option to say, I'm not interested in the capabilities, I'm not interested in the kernel namespace. So basically just filter out on what type of fields you want to have out of the events. I think is really important, otherwise you're dealing with tons of details, and then that will come with the price because you will store it somewhere. Other thing which is important is security agents could be very, 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 very noisy. So having the options to say, I want to throttle, to say, give me an event every minute or so, or limit it, I think it's important. And last piece, which is, I think, the most critical aspects, you're running a security agent. You want to know if my rules are being accepted. So have a metric to say how many rules has been running and accepted. Having another metrics about my security agents are running smoothly, they are not saturated. I think it's more than critical, because at the end, if you're having a security runtime that in your environment, but it's just not running, and you have no alerts, then it doesn't make sense to deploy it. All right, so let's go on this. So Falco. So Falco is producing the events on the rule-based engine, because the events is going through the rule-based engine, and then the rule-based engine says, yes, it's an event, so it's throwing it. So you can collect the logs from the Falco rule engine very easily by looking at the logs. But like I said, the structure of the log depends on the output defined in rule. And that comes very complicated to parse, or you have to create different parsers. That makes it very difficult. That's why we bring usually Falco Sidekick. Falco Sidekick is going to be allowing you to have different connections to different solutions of the market, and it will be pre-parse the content, and then it's going to be easy way. So at the end, you usually comes with Falco Sidekick, because at the end, it simplifies your journey. And the great thing when it comes to the metric, yes, Falco provides metrics about your rules. Yes, it comes with metrics related to the health of the agents, which is super important. And again, the notion of limiting and throttling, limiting is based on what you want to do on the rule itself, so you have to rewrite the rules. But the throttling aspects, yes, you can throttle. Tetragon, well, Tetragon produces logs directly at the agent level. And so you just have to read the logs from the agent. You will get everything. And you will see that the events produced is so long that sometimes even Observability platform intend to drop those because they are very expensive. So you will have to reconfigure Tetragon to just select the fields that you are really interested in. So that is a great option. And also throttling dimension is supported by Tetragon. And then when it comes to the metric itself, yes, Tetragon is insane. It gives you metrics about the agents. It gives you the metrics about the operator. It gives you the metrics about all the policies deployed. So you are good to go. You know what's going on in Tetragon itself. KubeArmor, well, is not producing anything on the log, on the agent itself. The philosophy is a bit different. You have to enable, so you go to the relay server, I mentioned that component, where you say, oh, please enable logging. And then the logs will happen on the relay server. So at the end, it's like they have a communication with the component, and this is how it's going. So either you go in that direction, or one thing which has excited me, because maybe I'm an Observability geek, is that they have an open telemetry receiver. And that receiver connects directly to the agent, so no need of the relay server, grabs the logs and put it on an open telemetry format, so then no parsing is required, and then you say, oh, I'm so happy about that. The only downside about this is that they build it on the collector version 0.96, and today we are on version 113. Yeah, you have to recode the receiver because it doesn't build with the new versions of the collectors. Or you use an old version of the collector, but with a security patch that is really recently happening, you won't take advantage of that. So it would be great to have this receiver updated for sure. Last is on the metric side. No, KubeArmor has no exporter. And I hope they will provide that soon. So at the moment you deploy, but you have no view on what's going on KubeArmor. So the only thing you can get is the resource usage, which is at least good, but you don't know if the policies are running, if there is any cache problem, anything. This is completely blind. Tracy, similar to Tetragon, will produce logs at the agent level. So you will be able to extract it. And like I said, Tracy is very structured event, except of the args, which just depend on the syscall that you're calling. So at the end, parsing is very, you can have a common rule for most of the cases, and then just for the specific cases, you can have a different parsing rule. So I think that is quite smart. It has, what excited me is that you have an option to push through the other protocols. They have a fluent forward protocol, which is supported by the OpenTelemetry collector as well, as FluentBit as well. And it has a webhook endpoint. So you can, if you don't want to use logs and you want to use the protocol, it works pretty well. And then in terms of metrics, it exposes metrics about the rules. Not so much about the agents, you have more on the error side. So if you have errors, you can imagine, oh, there's something wrong. But it would be great to have more details on the actual behavior in Tracy engine. So on the observability side, I think collecting events, yes, you can do it in most of all the agents that we have here. Extended the observability, yes, because at the end they are producing events, so no surprise. Throttling, I didn't add throttling and customizing the field because they all do it. But having metrics about the rules, having metric about the health, Tracy is doing it, not really, but they have some, I mean, at least on the rules, yes, but not on the health, it's quite lightweight. So all of them have it, so except KubeArmor in that regards. But yeah, if I will just pick one from the quality of the metrics, Tetragon is a beast on that side. All right, so let's move on to, oh shit, sorry, last stage 4. All right, cool. So what I did is I wanted to measure a couple of KPI, measure the latency that those agents will introduce, and of course the resource usage that those agents will provide. So to do that, I have defined a couple of policies, and I looked at the Falco default policies, and they were covering everything. So I said, okay, so I don't need to customize, I will use the default policy. Then I looked at Tetragon, I said, okay, I'm going to look at the Kubernetes API call, access to sensitive tokens, to sensitive files, any process spawn. So I create different policies on this. I did the same with KubeArmor about the similar policies. And then in Tracy, I added the default policy plus a couple of them to get the file details, the suspicious process, and so on. To be able to run that benchmark, I did a test without any agents to get a baseline, or the response times. And then I did a test with only Falco. Then I did a test with Tetragon with the default events. And then Tetragon with the default events plus the policies. And then I did the same thing with each tool. So KubeArmor, you can have KubeArmor with nothing, KubeArmor with the policies, KubeArmor with policies and events enabled, and then same thing with Tracy. Tracy, just the default policy, and then Tracy plus the custom policies as well. So a lot of benchmarks, to be honest, a lot of enjoy to run those tests on a daily basis. So I had to build different environments. So what's going to change within those environments? Here's the QR code to the GitHub repo, by the way. What would be different on those environments is basically the tooling, of course, and the actual collector pipeline, how you collect the data. And last is I added 2 apps that generate suspicious events in the background. So I'll skip those things. So let's have a look at the results. So just the constant load, so 50 users on the OpenTable demo, and the I'm sorry. So constant load with on the OpenTable demo. What I discovered here is like the Tetragon comes with an extra cost of 5 milliseconds. Falco is 10 milliseconds, KubeArmor 15, and Tracy 110 milliseconds. On the CPU side, Tetragon is consuming nothing, I mean, almost nothing. Tracy will be the most expensive one with 255 millicore, and on the memory side, Falco is consume the less memory, and then you have the most expensive is Tracy. Now let's add the policies. So I added the policies, and now we have Falco with 10 milliseconds, Tetragon with 26, KubeArmor with 176 milliseconds, and then Tracy with 114 milliseconds. And then in terms of CPU resource usage, it didn't change much, to be honest, compared to the first test. It's just add more override on the response times. And then I did, okay, let's turn on the events. So I turn on the events. The only one that has this option is the KubeArmor. So I turn on the events, and here I have almost half a second's difference with the baseline. And so I was quite astonished by those results. And as a conclusion, I would say, it really depends. So if you have security agents, all are great, but be cautious on the quantity of the events produced and the number of policies that you deploy, because it could have a negative impact. To summarize this aspect, I would say the most winner, I would say Tetragon is on the resource usage and latency, and Falco are great because they are very good over time. Because it's an Olympic game, I had to, so I did a different category of measurements. Every tool gets some points, and then I had to measure, to put some on the podium, because otherwise Olympics without podium doesn't make sense. So we have a gold medal today for Tetragon in terms of resource usage, in terms of the ability to do it. The only downside is the configuration aspects. Second one is close in terms of points is Falco. Falco is just in terms of resource is the most impressive agent. And last we have Tracy, very close to with KubeArmor, to be honest. So KubeArmor was close to be a third positions. But again, just to summarize, I say if you use those agents, make sure you limit the number of events. Make sure you deploy the right policies. Otherwise, you can have some surprises. I did a lot of episodes on my YouTube channel. Is it observable? Check it out. It's out there, and I will publish this benchmark in a week or so on the Observability channel. So more details on that. If you love it, love it. If you hate it, let me know, because at the end, with bad comments, it's the best way of improving your content. All right, so thank you, and if you have any questions, we have 1 minute, 9 seconds to answer any questions. So. By the way, here's the QR code if you for the feedback form of yeah. Sorry, go ahead.
No, I do have a question. So, from your comparison, it looks like you mostly look only on the cost of ownership part of these tools.
Yes.
And not really the security value. These are or observability value of these tools. So, are you planning to do a follow-up on that, and then comparing the security perspective?
I mean, for me, what I wanted is to capture events and be able to filter to detect those events. So that's why I didn't want to derive on the fact that they're all doing partially the same thing. But yeah, I was more focused on if I want to use those tools what will be my journey of using those tools if I'm not in the security space this many years.
Yeah.
And I think that I took that angle in this benchmark. That's true, yeah.
Okay, thank you.
I noticed in your charts you had a consistent issue with Falco memory usage, like
yeah, it started
memory
to
leak.
yeah, increased over time. But I used the ramp-up test. I didn't put, because I did a constant and ramp-up test. The ramp-up test didn't show any difference, to be honest, compared to the constant load, so I focused on the constant load. And then I tried to run a longer test to see if there was a memory, but it was not. So then it's like there's a, I don't know if the technology behind the scene, I don't remember, but it seems that the memory is cleaned up over time on that side.
Good.
So one other element is kind of extensibility with other tools and platforms. So you kind of mentioned that a lot of those things can kind of export things or send things into other tools, but are there any kind of limitations between tools for how nicely they play with other systems? Like if I wanted to split it off into my observability tool and start grabbing those metrics.
So could you repeat?
Yeah, sorry, it's a real. So I think a big concern is when you're maintaining lots of tools, a big ecosystem, you want to know that those tools can kind of have a variety of inputs, variety of outputs, and easy manageability. So from the output side of things, can you feed the data into just about any system, or are you kind of vendor locked into?
No, so every tool's, at the end, those are major events. So what I use a collector, to open telemetry collector. And then at the end, you can push it to Kafka queue, to whatever you want. Falco Sidekick is the one that has this connectivity tools that send to whatever you want. That has, by default, this tool. KubeArmor has also, I don't know if it's been maintained, but they did like the KubeArmor Sidekick, so similar to what Falco did. So you don't have to necessarily use the collector, but I think the collector gives you the freedom to send it wherever you want. That's what I thought.
Have you run these tests for different types of services, like a web service or database or AI workload?
So I picked the OpenTelemetry demo. That is a microservices architecture with 12 microservices with Redis cache, Kafka queues. And then I had Unguard, which is an application that is using SQL database. So it's a PostgreSQL, a MariaDB database. So I had two applications. Unguard was intended to be vulnerable, and I had a load generator that do attacks. So then my intention was to produce events in the background. But yeah, I was covering a representative microservice architecture.
Very entertaining and educational. Thank you.
Thanks.
Like tests? Cool. So regarding, I love your experiment design, first of all. Question about Falco specifically. Did you see any performance differences between kernel mode versus ebpf and any of the other modes that Falco could run under? And would that affect your scores here? Or is that something to consider in the future?
So you're referring to the latency or the?
Latency, performance, both.
Yeah, I think the latency in general, what I discovered is that in my cluster at least, lower than 10 milliseconds, it was impossible. And then from the moment you start having very noisy agents, I would say, then the latency threw up in the roof. And then also it depends on I did a policy and then I removed it because it was basically checking the networking communication. I wanted to check the header. I mean, I wanted to do something weird, maybe not very useful, but I wanted to see if I started to interact with the TCP layer, if it will impact the response of the app. And yes, it did. So that's why at least when you design your policy, it could have a significant impact on the latency.
Great talk. Thank you so much.
Hi, I just have a question. So there's a thing called Falco tenant. It is kind of doing kind of operation like block based on the Falco event. I'm wondering, so you say like Tetragon 8, you could customize your hook point, which means you can actually kill the process before it gets the capability or it actually call that function.
Yep.
But for Falco, it's actually just generate event. So basically, if you do something based on event, which means that operation already happened.
Yes, that's true. That's
Am I understanding correctly? So basically,
So it depends where you're, because you can. I mean, in the case of the process, you can make the events when the process has been started, or you don't do at the exit. So then the process will start, but you will kill it in the middle of the execution with Talon.
Yeah, but let's say this process, it doesn't supposed to
Execute.
To do something. Oh yeah. Let's say it's suppose not getting, like for example, open the network connection, and if I see it open, can I see the event that it's trying to open but not open yet from Falco?
It's a great question, to be honest. I'm not sure. To be honest, I need to double check with one of the maintainer of Falco about this, but I'm not sure, to be honest.
Okay, sounds good. Thank you very much.